Okay, so this lesson is starting in Unit 2 now, gets into quadratics. So Unit 1 was linear equations. Unit 2 is going to be all about quadratics. Actually, Unit 2 and 3 for that matter. So the first thing we're going to start off with is a little bit of review with factoring. Now, there's nothing we're doing today or doing in this lesson that you have not seen before in some fashion. I'm going to show you maybe a little bit different way of factoring, might make it easier, and hopefully this helps. This is something that kids either just get or they really struggle with. So hopefully seeing it again here will make a difference. So there are three types of factoring that we're going to go over today. There's traditional factoring, which is what you're probably most familiar with. You use your AC method. You might have to take a GCF out first, but there's nothing tricky about it. And then there's factoring by grouping, which is factoring if there's 4 terms instead of these, which you see are all 3 terms. And then there's factoring by difference of squares, and we'll get to that at the end of the lesson. So let's start off with our traditional factoring. Zoom in here. Perfect. So we have our first problem here. Now, if you remember how this worked, you did your A times your C. And that was negative 24. Okay? And then you had your B, which was negative 5. And you had to find two numbers that, when multiplied, would multiply to be negative 24 and add to be negative 5. So now you can mess around with numbers. You know, there's 1 times 24, 2 times 12, but you probably would settle on that it's 8 times 3. 8 times 3 is 24, and I can somehow make that work to be negative 5. 8 and 3. How do we use 8 and 3 to get negative 5? Well, if we use negative 8 and then a positive 3, that's going to give me the negative 5 that I need. And positive 3. So negative 8 and 3 is negative 5. And then, if you've been in my class before, you know the term dead cartoonize. I like to use dead cartoonize. I go right to my parentheses, which I call dead cartoonize because it looks like, the set of parentheses looks like eyeballs of a cartoon character. When they die, they got X's in them. And then all you do is drop down your factors. And that's it. So that's your traditional factoring, where basic A times C has to match up with your B also, and then you drop it into your factors. Sometimes the work requires a little bit more, tricks here. So you can see in this problem, first of all, one thing you have to notice is this is an x to the third. That's a problem. This is not a quadratic, this is the cubic, so we can't have it like that. So what you should also notice is that all the terms have an x. So it might be beneficial to maybe factor out an x out of all of these. So I can take an x out of this. Essentially, you take an x away from each term, making that now x squared, and negative 5x, and then minus 2. Now it's a quadratic, and now I can factor using the traditional ways that I did in the previous problem. A times C is negative 6. Here B is negative 5. I need two numbers that, when multiplied, is negative 6, and the same numbers need to add to be negative 5. Now be careful here. You might want to jot down some of the things that multiply to be 6 in the first place, like maybe 1 times 6 or 2 times 3. You have to be careful here. It has to add to be negative 5. So you could do negative 6 and 1, or you could do negative 2 and negative 3. The problem is only one of those will actually multiply to be negative 6. So let's say you chose, you know what, I'm going to do -2 and -3. Sure, -2 and -3 is -5. But if you multiply -2 times -3, you don't get -6, you get +6. So that actually doesn't work. You have to use the other form, which is -6 and 1. -6 and 1 is -5. -6 times 1 is -6. We then draw our dead cartoon eyes, so with the X's in them. Drop down our factors of -6 and +1. Now here's the trick. Here's the trickery here with this particular problem. In our previous problem, our A, right there, the number that's right in front of the x squared, our A was 1. Well, there was no number there, so it's 1. And when your A is 1, you don't have to do anything once you get it into its factored form. But if your A is 1, or not 1, like this, it's 3, we have to actually divide our factors by that number. Now, if the numbers are evenly divisible, like this, 6 divided by 3 is an actual whole number, then you just do that. -6 divided by 3 is -2, and so you get x minus 2. If, in the case that it's not divisible, you cannot have a fraction in your factors. So what you do is you pull the denominator out in front of the x. So it becomes 3x plus 1. Now all that's left to do is drop down the x you factored out in the very beginning, and you're done. Okay? It seems confusing. Please rewind the video and play it back, but that is traditional factoring. What you want to do now is try the problems below. Go ahead and try them out. Pause the video, try both of them out, and see what you get. Play the video when you're ready to see the answer. Okay, here are your answers. The answer to the first try problem is 2, because you factored out 2, and x plus 2, and x plus 1. The second problem, let's see if I can do this here, is 5x minus 3 and 2x plus 1. If you have questions, please don't hesitate to ask me how I got these particular answers. Now let's move on to factoring by grouping. As you notice, in grouping there are 4 terms, and that's sort of the giveaway that you're going to be using grouping. Grouping, if you remember from Algebra 1, is the simple act of just pairing up the first 2 terms and pairing up the second 2 terms and taking out a GCF for each one. So in this one, I'll take out a GCF. The greatest common factor between these is 3, and they both have an x, so 3x. When I divide out a 3x, 6 divided by 3 is 2. One of my x's is missing, so now it's just x. 9 divided by 3 is 3, and I took the x away, so it's no longer there. Second set. Now, the second set, there is no GCF. Well, so you think. There's always a GCF. And if you can't think of it or you can't see it, it's probably because the GCF is just 1. Okay? So because no other number goes into 2 and 3 other than 1, 1 is your GCF. And 1 doesn't actually change anything because you're just dividing both of these by 1. What you should notice if you grouped properly is both of your parentheses should be the same. You then take your GCFs and pair them in the same parenthesis, and then your common factors in the other. And that is grouping. We can even do it with multiple variables. So you can see here, there you go. We can even do it when you have multiple variables here. It gets a little tricky this way, but it can be done. So group our first two terms, group our second two terms, take out a GCF. In this case, I can take out an x from both of them and a y. So x, y will come out. No number does. No number comes out of 1 and 2. So I take away an x and a y, I have x minus 2. In the second one, I can take out a number. Since the first number is negative, I'm going to take out a negative 6 and a z. What's left over is just the x, and 12 divided by negative 6 is negative 2. Now I know I factored this properly because both of my factors are the same. I pull my GCFs together in one parenthesis, so xy minus 6z. And the common factors of x minus 2 in the other. That is grouping. So go ahead and try the problem below. You can try that one in grouping. Pause the video, try it out on your own, and play the video when you're ready for the answers. Ready? Here's the answer. 5x plus 4 and x plus 2. If you're confused as to how I got that, please don't hesitate to ask me how I got this answer. Okay. Last one. Flip over to the second page, and I have factoring by difference of squares. This one might not be as familiar with this one as the other two examples. You didn't see this too much in Algebra 1, but basically what gives this away is that there are only two terms. So think of two terms, you try difference of squares. 3 terms is traditional factoring, and 4 terms is grouping. So here I have 2 terms. But the one thing that gives it away is that both of these terms are perfect squares. X squared is a perfect square, and 81 is a perfect square. So we can skip all the sort of AC method and go right to our dead cartoon eyes with the x's in them. Okay? And all you do to fill in your factors is simply square root each of the terms. The square root of x squared is x, and therefore the x will go in the first term of both parentheses. You fill in a plus and a minus for each one, and the square root of 81 is 9, so you fill in 9 in the other spot. The reason why you have no middle term here is because it canceled out, which is why one has to be positive and one has to be negative. That way, when you factor it all out, the middle term actually cancels out because of the positive and negative. So that's why there has to be a positive and a negative there. So let's recap. Go right to your parentheses, square root both terms. The square root of the first term will go in the first spot of each parenthesis. The square root of the second term will go in the second spot of the parentheses. Let's try one more. Okay. Another difference of squares here. Notice that 4x to the fourth is a perfect square. 16 is a perfect square. So we can go right to our parentheses, and we're going to square root each term. The square root of 4, okay, is 2. The square root of x to the fourth is x squared. So it's still in the first term because we're still doing the square root of the first term here. So 2x squared and 2x squared. We place a plus and a minus to make sure that that middle term cancels out. And the square root of 16 is 4. That's it. Okay. That's it. That's factoring using difference of squares. Now go ahead, and now you could, technically this could go further. You could factor this further, but for now, we're just going to stick with just the basics of finding your factors. So that's it. So there's a try problem here. Go ahead and try the problem down here on your own. Pause the video and play the video when you're ready for the answer. Ready? Here's the answer. 4x plus 7 and 4x minus 7. Okay. So that's it on factoring. If you got stuck on any point, just replay the video and go back. Practice the questions in Big Ideas. And if you have any questions, let me know. Otherwise, good luck. And there is no outcome quiz for this particular module, but it will be on the next module. Thanks.